share my screen then?
Yes, should be able to. We are seeing, yep, there's your slides.
There we go.
Good.
Yeah, so this is, like, we came up with a term, it's called a 3D approach to enterprise systems. I'll be getting into what I mean by a 3D enterprise approach to enterprise systems, but it really is tackling the issue of integration and aggregating data between systems. And in my mind, it goes right to the very core of how we create systems, and that if we want to solve it, we really need to kind of step back and rethink this. So in terms of the purpose of the presentation, I would hope that with this presentation, maybe, I know that everybody's busy and they've got their, everybody's working on their own initiatives and stuff to try to make things better. And I hope that there will be some content within this presentation that will maybe add to that conversation, and maybe think of things that that this could contribute to addressing the issue. So that's what I hope. I mean, we have a lot of people in this meeting that have a lot of expertise and experience, and so in terms of an introduction, my name's Blair Kjenner. I started software development in 1982. Interestingly enough, most of my work has been with what I call enterprise systems. And I consider, so this isn't all software, this is really that financial administrative software that sits in the middle of organizations, and then you have your operational systems around that. So it's really, that's what I consider to be, just so that we have the terms correct. So that's not necessarily their websites and stuff like this. It's really the core financial, administrative, operational systems that exist. And so most of my effort has been in developing and creating those systems. I started my company in 1984. And we assembled a team, and we create systems and then outsource the support for it. And I've worked in all kinds of sectors, the government, municipal government, what we call provincial governments, associations, oil and gas was kind of big. So a number of different initiatives like that. In terms of how this initiative came to be, it really was back in 2017, and I got the chance. It was just kind of a bit of a sabbatical from just creating and maintaining systems, to actually go in and help an oil and gas company find missed revenues. And so I worked with an industry expert that was a production accountant, and my job, and I should mention this, in my whole career, I've always been involved in kind of the back end technology parts of it, not so much the front end technologies, but the back end, the database and stuff like that. But so my job was to go in, and we really took it the way that we normally do. We created a corporate data dictionary. We reverse engineered. There's about 30 systems, so nowhere near 6,000, but there's about 30 main systems that they had. And we took, I think I took about a dozen of those, reverse engineered them, got the schemas, got the data dictionaries, all that, and created this corporate data dictionary, developed a bunch of tools that would allow us to connect that data all together, across all the systems. Developed tools that helped us find anomalies in the data where data in one system didn't agree with data in another. I passed it off to the accountant, and we ended up finding 7.5 million that they missed in billing. And it was, and they collected it. So it was not just, we found it and that's very nice and thanks for your time. It was, we actually found money that they actually collected. And I think in the process, and we're all data people here, but when you go in and you reverse engineer these systems, you truly see how disparate these systems are. And, they are really designed from, based on no conventions, it's really based on the personal preferences of the teams. And this isn't just custom software. This is packaged software too. The biggest ERP systems, it applies to everything. We basically, everything is really designed according to the preferences of the development teams. And so in terms of, I guess the problem needs analysis here is really the methodologies that we have for creating any kind of software, enterprise software that is, has severe limitations in our ability to easily integrate and aggregate data across systems, right? It's really, and it's something that I go back quite a few years. I guess it's 40 years now, but it even goes back further than that, right? It goes back, to the beginning of time in terms of, in terms of how we've created systems. We really haven't changed the way we've changed tools, but in terms of our methodologies and stuff, we haven't really changed, anything from that perspective. And so in terms of, why, this is my take on why integration is so difficult. I say that the databases that we produce are as unique as a fingerprint, right? Every database is unique, and, so when you reverse engineer the systems and you look at them, you'll see, well, geez, tables are named and, columns are named differently for the same data in every system, right? So if you go across all these systems, and I personally believe, I guess this is my own number, but I believe that 60% of the data is like this master data, and much of it is common across all the systems. And when I say, I'm talking the reference tables, lookup tables, that master classification data. There's a lot of it, and it's really, it's prevalent and common across all the different systems within an organization. The other thing that you see when you try to integrate these systems, well, it's different primary key methods. One team will say, oh, geez, I like incremented integers. The next one says, oh, geez, I like GUID. The next one says, oh, I like composite keys. And they choose whatever primary key method, they like, and then implement it. And so in the end, we end up with this master data that is replicated across all these different systems. Everyone has different primary keys. Everyone is structured differently. Like when we were looking at oil and gas records, well, one system had, 50 columns. The next one had 70 columns. The next one had, it was a varied number of columns. And even when you get down, you say, oh gosh, well status, perfect. We got well status. Well, no, because one system has, 5 well statuses. The next one has 9 well statuses, and you can't even correlate, across all these different systems, easily. So I'm preaching to the converted, I'm sure here, but at any rate, so we have this master data. It's different, it's structured differently, different primary keys. Unsure what the gold version of a record is. We've got the same record duplicated across many different systems. Well, which one do we trust? And it's not always just one system that has the trusted record, right? Because when like in oil and gas, when a record comes in, well, first it's maybe the project management system has the gold version of that record, and then there's a contract, and now the contract management system has it, and then production accounting, and the field data capture, and depending at what stage it is, it will dictate which one is going to have the trusted version of that record. So, so we have all these things, and now we try to integrate them. And, there's this one little this one little GIF, I guess it is. I was going to show it. I didn't want to be too negative, but it's showing how you can take all these different systems and you just plug in another system and it goes chick, 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 and it aggregates all this data, and poof, out the end comes a data warehouse. It's all, and it looks like you can just throw one more system in there and boom, it just does it, right? And So things like that drive me a little bit crazy because when you start looking at all the challenges of, of all these disparate systems and stuff, you realize that the more systems an organization has, the more it's going to struggle with integration. So what issues? Well, really, we build these systems for our clients, right? I mean, this isn't just for fun. We build it for our clients. Now, in these guys' case, and I don't think it's, it's different for anyone else, they have to rekey data from one system to the next. Ensure we integrate, and even our definitions of integration are really loose. Like if we take one system and integrate one table with several columns, boom, it's considered integrated, Like it's certainly not integrating on every column and every table within that system with every other system that exists. So it's inefficient. Users are keying and rekeying data from one system to the next. Overly complex business processes, like what would we do without Excel? We have a limited ability to produce management information that spans many different systems. We have a limited ability, to leverage AI. And, I think that what's been happening is in the original creation of systems, everybody's just happy to get a system, like automate a business process, and that's great. Now we're seeing with AI and, the importance of data that now it's not okay to have all these disparate systems and to, and not be able to integrate them. So I also think that our approach to systems makes very, very expensive systems. The amount of functionality that we duplicate across all these systems is crazy. Every system has authentication, methods, and it's got systems, for defining how the menu systems work and how you browse and edit and, drill down in data, and everybody's designing all that stuff from scratch. And so we have a tremendous duplication of effort that exists. So what are we doing to fix this? Well, this is kind of what an organization looks like. It's got all these disparate systems. Nothing is tying together. Or when I say nothing, there's minimal integration, that's occurring. We tried to do things like master data management, which is really just kind of a manual process to try to get some commonality and keys across systems. But we still struggle to take data from all these systems, and even if we had a perfect master data management program, to take all the data from all these systems and push it into a data warehouse, and then to automatically update it when it changes. That is, that would be a massive effort, no matter how good those things were. And the tools are really just icing on putting icing on. I think they talk about icing on a turd or something like that. It's kind of like, it's just like, it's really just it's really a superficial, after the fact approach to it that doesn't really ever that costs a tremendous amount of effort. In fact, as an industry, we seem to have no problem creating all these silo systems, but we're totally prepared to spend all this copious effort to try to integrate the data after the fact. So, so again, I'm preaching to the converted here, but so the big solution is to implement a bigger system. And, so then but those bigger systems, whatever it may be, they were developed as silo systems, right? They were given requirements, they defined that system. Like, I challenge the big vendors to take their systems and say you took like an SAP and you say, okay, I want you to implement separate instances of SAP in every department in the government. So each one has its own instance of that. And by the way, I also want you to hook in systems for education. So they all have their own systems. And, and then I want you to aggregate, tie it together so that data is only ever entered once and shared across all the systems, and so that we can automatically aggregate the data. Well, I've looked inside these systems, and my opinion is they couldn't do it, because they didn't architect those systems from scratch to accomplish that. They didn't have primary key methods. There was no way of determining what the gold version of a record was. There's no way of automated transfer mechanisms. And yes, they can do, I can't remember the term, but some are doing it. but effectively they're then stuffing everything in the same database. And anyhow, so that's my perspective. I'm sure that, everybody's, kind of got their own here, but the bigger systems, Dave, you had a thing on this, is you say, creating systems is not like manufacturing widgets. We can't take, we can't just ramp up production and create more widgets. Every functional point is another functional point that gets added to the system that increases the complexity, and at some point we hit the wall and we can't add one more functional point because this thing implodes in its own complexity. And that's really what we've tried to do to address integration issues, is just put it in a bigger system. Yeah. But it doesn't eliminate all the other systems, and now you are 100% connected to that vendor with little ability to change and little ability to to change your software, kind of like after the fact. So
Blair, can I just put my little spin on that a little bit? Because I mean, you're dead on because you're quoting me. But what I used to say was, everyone knows what economies of scale are. Every time you double the amount of widgets or shampoo or whatever it is you produce, there's a very predictable decrease in the cost per unit. But with software, every time you add another line of code, instead of it predictably going down, it predictably goes up. And the difference is every line of code has to coexist with every other line of code, whereas every widget or every piece of shampoo doesn't. And it's just that difference in complexity that makes one go down and the other go up exponentially.
Yeah, it's true, and really that's been our golden solution to deal with integration. Let's stuff it all in one big system, and then we'll have the data integrated, right? We can have it, go to AI, but it's a flawed solution. And I believe as an industry, we're going to, we're not going to be able to take on the and I'm going to give you some examples of, but we've hit the wall, and in terms of how big these systems can get. So the root cause is we have, an integration last approach. We define requirements, design a system, develop it according to whatever personal preferences we have, implement it, and then let's try to integrate it. And the more systems we have, the more difficult it becomes. It's an integration last approach. We've always had it, and now we're getting now it's getting exposed as a true problem because of our desire to integrate systems and to aggregate data across systems. So what is the goal? Well, I think we need a stretch goal for our industry, right? And we can't be afraid, like all of the systems that are out there, they're going to eventually get replaced. So why not start to think about replacing them based on a methodology and an approach that is designed from the bottom up to be able to achieve today's standards for integration? Why not? I mean, why would we continue to create disparate silo systems forever? So that's really, I know it's a lofty goal, and people look, oh God, look at all the software that's being created. How could we do this? But at any rate, so to my mind, the goal is to create enterprise systems that have an inherent capability to securely exchange data. And I see it as...
Blair, here's another quote you might want to put on your slide. I think it was in the late 90s that Martin Fowler used to say, the legacy systems of the future are being created today.
Yeah.
It couldn't be more true. That was 20 years ago. 20 years ago. Look at how many legacy systems we built in the last decade. Yeah.
Well, no kidding, right? And it's really a mindset change. But the way I see it, and you're going to see this, well, anyhow, I see that our goal is to create this network of systems. And then you would have like a subnet network that is satisfying the needs of a conglomerate like government. And those subnet systems are connecting to other systems that exist out there. And I'm going to just show you a little bit about what that looks like. So I actually set up a full proof of concept system. There's no user interface, so this is just the platform that exists in the back. These, and then I took a government. And so each one of these, you know, so there's like a system for the executive office and a system for the citizen registry and a system for the vehicle registry and the energy department that controls oil and gas and the corporate registry and public works and land registry and municipal affairs. And then I set up some external systems just to, you know, it's a proof of concept. So it's like I said, oh, well, we could have a couple of municipalities that need to share data in here too. We could have a bank. The bank might have an interest because there's land. There's, you know, encumbrances on land properties and stuff that they might have an interest in. We have consulting companies. So I just was this proof of concept environment, which is developed, and there's a tremendous amount of effort went into doing it, but it tests the platform based on the philosophy. So the idea is that, you know, like if there's an update to a citizen, then that data just gets broadcast to any system that's on the same subnet. But it doesn't just go, poof, update the database. There's capabilities to say, no, I want to review every change, or, you know, there's all the kinds of rules. Yes, this is a kind of change coming from this trusted guy that I'm going to actually update the database. No, this one I want to review and approve every change before it comes in. And it basically does that. And even external entities, trusted external entities. So a citizen, well, they may have an interest in, you know, they may be in a municipality, you know, so now we need to update their name and address information there. But it also applies to like a land registry update. Somebody gains title to a property, you know, and so that gets up, you know, so maybe there's an oil and gas well on that property. And now we need to update that oil and gas record. And well, it certainly is going to affect the municipalities in terms of who the titled owner of that property is. So the update's got to go to that perspective. We have municipalities collecting data, you know, about, you know, the mill rates and assessments and all that stuff for properties, and pushing that data into, you know, like a municipal department, and all of this stuff occurring automatically. We have corporate updates. A new corporation, you know, gets formed. I'm not going to go through all of them, but we have like project updates, like project activity systems where, you know, there's a project that gets initiated and it's affecting all the departments, and we have outside companies working on this stuff, and we need the ability to aggregate and pull all this data together across all these different systems. And, you know, we have finance stuff. So anyhow, that's, I'm not going to go through all of it, but there's so much more than even what I'm showing you in terms of the kinds of use cases and things that were being tested to show how all this data can flow across all these places. And another key part of it was that there's a data aggregation engine that automatically aggregates data from all systems into a data warehouse. No programming. It's just, you know, because all the systems, because we did it from the ground up to do this, it can be accomplished. And, you know, I know as a group, you know, if we said, hey, this is our goal, we're going to do this, and we said, oh, let's, you know, we could do it, right? This is not an insurmountable problem by any stretch. If we said, wipe the board clean and say, let's rethink how we create systems. So at any rate, so what have we done? Well, I'm going to go through the principles. I should do a time check here. What time do you want me to finish up here?
Half an hour.
Yep.
What's this?
Yep. You're halfway through. Half an hour.
Oh, okay. Okay. So I have something at in half an hour. So we'll have to kind of finish up. Is that okay?
Oh, yeah. Yeah.
Okay. Okay.
Yeah, we're done in half an hour too.
Oh, good. Good. So what have we done? So I started off by saying, okay, what's going to be necessary if we're going to be able to accomplish this? And so I came up with 5 principles that I thought were going to be necessary if we wanted to be able to fully integrate systems and aggregate data. Then, you know, it's like I put that out on LinkedIn, got comments from people, you know, kind of spread the word a bit, you know, kind of interjecting and getting ideas from people to try to figure out how to, how to evolve these. Then, of course, principles are one thing, but it really, the rubber hits the road when you actually try to develop it, right? Because you can go and try to develop it, and it's like, well, that's not going to work, and the performance issue here or security issue there. But so actually develop the whole platform, which would be the concept is that you'd be able to download this platform, create, which would be the starting point for a system, and then extend it to meet the unique needs. And then produced a whole two different actually test environments. The first one was just a straight test environment. The second one was a proof of concept environment. Documented the approach with videos, published a book on it, published a website I tried to throw everything in there, the principles, the, why we're doing this. In fact, I even, I don't know how much you guys are aware of technology co-ops, but I felt that this was really, it would be a really great perspective because it's open source and it's really like doing like a tech co-op kind of a concept in terms of where the people that contribute to this become effectively the owners of it. I mean, I did quite a bit of work on the website on a tech co-op that you might want to check out. I was just kind of throwing it out there because what I didn't want was one more private corporation that's creating software that is just another, silo system. I felt like we had to get back to, doing this as an industry. And so that it was all kind of pitched based on that idea. And that's why there's quite a bit of content on the thing about this tech co-op and how it could work. So at any rate, and all the source code is up there too. The videos, I did like 25 videos. They're all up there. Like it really is my, my approach to, really trying to deal with an issue that I feel is critically important. And of course, I should mention that Keywall, I've had involved, he's been such a big supporter right from the beginning when I first started talking to him about this. And he would be really approaching it from the education perspective on this in terms of, educating and certifying resources to leverage these principles. So I'm going to go through the 5 principles. I'll do it fairly quick, but the first one is we have to create systems based on core models. Now, you can't really see it there, but in the center, we have a core, which represents the common data that we would, that we would see with, every system. Then we extend that to, the attributes and tables necessary to meet unique needs within, say, common business entities, I guess you could call it. So it would be like, maybe you've got, at the core, you've got like a retail organization. So at the core is that core data that's common to every organization out there. And I'll get into what that is. At the second level is the data that would be common to these retail outlets in general. And at the third level is data that is specifically designed for their own purpose. So it's really kind of dealing it within 3 tiers. So in terms of what is core data, well, it's the data that we find in every organization. It's, every organization has contacts, finances, assets, activities, and it's really coming up with core structures. And Len Silverstone, he wrote a book on, universal data models, and, even the ERP vendors use the concept of core models. I mean, when they have their core contact systems and their financial systems, and, and when they go into a new industry, they're not saying, oh, well, geez, what you have transactions and you have journal entries? What? It's like, so they take those core structures and then augment them to meet the unique needs of all these different industries. So and I think that there's one critically important rule that goes along with core data is if it isn't in, and I came up with a threshold of 80%. If it doesn't exist in 80% of systems, it's not core data. Like, this is not about coming up with an address record as an example and having 250 attributes about an address, about every possible attribute of an address that everybody could ever have conceived. This is a less is more philosophy. So we use a philosophy like a threshold to decide whether things go into the core model or not. So I think that's a really important thing. And then the models are really designed to be able to extend. So the reason core data is so powerful is because it's static. Like, when we start looking at what are the common attributes that we see that exist across all organizations, that hasn't changed a lot. And so because it's so static, we can start to develop software based on them. And then we can we can extend them to meet unique needs. So we don't, so they have to have data. They can have embedded standards built into them, naming convention standards in the way that we structure data. They can have features baked into them. In fact, all the core models that I've created have features like audit logging, so that this change history, audit log capability is built right into the model. Temporal. Temporal is a big one for me because it's like, so often we create systems and the systems are based on what that data looks like today. And that's how the system is architected, based on what the data looks like today. But there's so much data that exists in systems that is temporal, that is time sensitive. And you should be able to go and look at your data and say, okay, I want to go back and I want to look at my data as if it was December 31, 2022. And now everything reappears. Now, if we were looking at a land system, then it would be, well, who is holding titles at that time and what were the encumbrances at that time? And so it's temporal is a really big one for me, and that's built into it. And also features like data exchange. The core models would be expanded to deal with new subject areas, things like contract management, HR, so we probably leverage some of the works of people like Len Silverstone to add in those new, subject areas that, that need to be addressed.
So Blair, have you published these models, or at least the core of your core?
Yes, yeah. Yes, the core of the core is in the book, and I am, totally open to, and this is where getting other experts involved, right? Taking the core structures, testing them against different scenarios, extending them, and so on. So it would really, this is why I was really, thrilled to talk to your group, because, to come up with and say, hey, this is, this is the Estes Park group that, is going to, has taken a look at this, and now we want to take these core structures and these philosophies, and we want to take this as, and take it to the next level, right? So the other things is that when we create industry models would have at the core of them the core model, and then you have an industry model, and then that sits on top of that, but it blends right into the core models. So now the core becomes common across all industry systems, things like contacts. So now it means that we can easily move financial transactions, contacts, activities, assets, things like that. We can start to move all that stuff between systems. Architects can use what they feel is applicable, based on what they need. And it's really the first cornerstone to being able to exchange data between systems. So the next one is primary keys, and primary keys is a massive one to me. Just like I feel as an industry, I'm going to be bold here. We have done a poor job of primary keys. Like I feel like almost no thought has gone into primary keys. So we have incremented integer. Well, we love those. They're super small. They're fast. But as soon as you start to aggregate data across many different systems, now we're getting primary key collisions. and then we came up with GUIDs, and GUIDs is like, I know there's different variations of it, but in general, it's give me the biggest random number that you've ever thought of, or that you could ever conceive, and we should never be able to collide, but they're inefficient, they're difficult to reference. There's a lot more review comments that I had in the book about it, but composite keys is surprisingly, and I could be wrong here, but systems like SAP use composite keys, right? There's so many issues with composite keys and trying to create, first of all, they're bulky. They are very difficult to create common source code based on keys that are continually changing in systems across, especially when you start wanting to do audit logging and transferring data between systems. Composite keys doesn't do it. And to me, GUIDs everywhere is from a performance perspective, and plus you need intelligence in that key. And so
wait before you go on. I mean, did you look at URIs or IRIs at all?
I do not. No.
So pretty much what the semantic web standards are based on. I mean,
Yeah.
I kind of like this presentation because it does lay out the problems to be solved, but I think they're pretty well solved with URIs. I'm not quite sure what you're going to suggest, but fire away.
Well, let's see. And this is where we're getting feedback from other people, but it's like so in terms of the primary keys, I guess really the challenges are there's a bunch of different kinds, and and this is and developers choose whatever they like. And I mean, we should be able to assign a primary key to a record and never have it changed, no matter how many different systems it gets transferred to. I mean, when we start aggregating data from many different systems, that data has, transactional data has to be able to come in and get blended in with other transactional data and not have it, not have primary key collision. So I think, to me, the goal is, you have to generate it once for a record, and it should never change no matter where that record goes. It should be as compact as possible. It should be, flexible to be expanded, like IP addresses were, and it must be consistent across all tables and systems. So it's not like we're choosing to use it in one place but not another. In this case, I did, I came up with a method I felt it worked, pretty well. It has a system ID and a record ID component to it. The system ID is it's kind of like our IP addresses. When we solved the problem with IP addresses of having some intelligence, you can imagine if IP addresses was a GUID, right? There's intelligence that's built into the key there. And so the system ID identifies the original system that created the record. Now that is really, really critical, because when we get to record governance needs to know when we create a record in a system, it automatically governs it. And then when we transfer that governance, and I'll be getting into that, it's critical.
Blair, if you substitute system ID for the domain name registry, you'll be pretty close to what a URI is.
Okay, well, perfect. So maybe there's a way to blend that in there. These are 8 bytes long. So it's half the size of a GUID. It can store 1.8 million systems and a quadrillion different record IDs. It's easy for users to reference, like 33-1 is system 33 and the first record in that table. It's unique no matter where it gets transferred. It's automatically created whenever records are stored, and it's, as I was mentioning, it's useful for record governance. Now the record governance principle is really saying, okay, if we've got the same record and it exists in 20 different systems, then which system do we trust? Which system is our trusted system, right? So by default, the rules of record governance is whenever I create a record, I automatically govern it. And then I can transfer my governance to another system. So that could be like I created, maybe I'm a membership system, and I create a member, and that member comes in, so I create them in my system, but eventually that member moves to a different district. So then we transfer the governance to the other district, and then I become a subscriber to the any future updates for that data. But you have to be able to transfer governance between systems, so you always know where the book of record is. So that's what really record governance is. And so that it really helps us to know which system. So I feel like that is important. Like if we were coming up with this new way of creating systems so that they can automatically integrate, well, we better have record governance, because if we duplicate records all over the place, we're going to have the same challenges with trying to aggregate the data. Data transfer is like each one of these is kind of my rudimentary conglomerate, right? So there's these conglomerate systems, and they don't always have to be hierarchical like that, but it's really transferring the data between the systems. And so with data transfer, you can, it's, like it's not as simple as it sounds, because it's like when you have a record, that record is a hierarchical grouping of data. It's like I'm subscribing to the contact, but I want the address, or I'm subscribing to this land parcel, but I want the title holders as a part of that. So there's this. It's a hierarchical grouping of data, and the subscribers is a hierarchical grouping. It's not like, so it's like if you had your retail group. As soon as the retail group subscribes to data, then they get everything that retail group gets. And so this whole mechanism is all around being able to manage all these groups. And when something changes, it's automatically broadcasting the updates to all the systems. And the audit logging is another really critical part of this, because whenever data changes anywhere in that record grouping, we have to be able to detect that change, bundle it, and then send it off to the other systems that need to see it. So so that's a quite a complex thing, but it's all working in this platform that I created. So it's got to be, data transfer has to be built excuse me, right into the core data of the system and be available for when new data, it gets triggered whenever new data is added to the system or whenever it changes. So I kind of talked about that. I mean, there's a lot of features that were built into it, and this is where when you start to actually get into creating the software, you realize what you need to be able to do. And so when we're subscribing to data, we can subscribe to a single record, to a whole table, to filtered records. Like as an example, I'm subscribing to address records, but I only want the home address, right? So it's like that. So there's those concepts. Or if it's a reference table, I want the whole table. I don't want, so when any record in that table changes, I get the update. The whole structure is all around publisher systems and subscriber systems being able to modify their data structures and being able to catch that and accommodate it. And so that's built in, so that if like a subscriber system adds a new column, changes a business rule, changes something, it will capture that and deal with those anomalies. And then there's basically varying levels of control in terms of how those updates get applied to the database. So I feel like this, so this mechanism should take care of a substantial portion of integration between systems. But that's not to say that we still couldn't create custom integrations where we wanted to. Right, so we're not precluded to using, strictly this data exchange mechanism, but it would deal with most of the data exchange requirements that we got. I'm just going to talk a little bit about the application framework. The application framework to me is that the features like, security systems for authenticating, menu systems, data maintenance systems for searching, browsing, editing data, workflow. And my thing is, when I look at our industry, I would say if we've created 1 million systems, we've, almost that many times we've recreated application frameworks, and it's a tremendous duplication of effort. And they're just like, when we look at core data, there's core functionality that should be in this. And I feel like the application framework should be more like a web browser from the perspective of being able to define parameters that define what the enterprise system looks like, and then running it through the equivalent of a browser so that we can change browsers, which may have, just like we can go from IE to Chrome to Edge. You should be able to change enterprise browsers, and likewise, organizations should be able to create their own application frameworks. So I'm not going to go through the kind of all of this in terms of, but in terms of what the next steps are. So I think that a fair amount of progress has been made in terms of, writing the book, developing the platform, proof of concept environment, kind of getting it all out there. And then, but the next thing is to create the application framework. And actually, interestingly enough, in the last month, the application framework is the UI portion. Is that it was that, that kind of a web browser concept that I was talking about. So we're just starting to look at creating that. It would be helpful to have additional resources to help with that. But at any rate, developing education, certifications, monitoring in terms of certifying resources to leverage these concepts, developing a governance model in terms of how do we make changes to core models, how do we make changes to core functionality. So there's some work that needs to be done there. Select a system, select that very first system to create with this model. So if somebody's saying, have you implemented this model yet? The answer is no. I mean, we're still creating, the application framework. I think we've made a lot of progress, but the application framework would need to be created, and then we would need to be implementing that first one. It incorporated with other disciplines. At the core of this, you have this core architecture for enterprise systems, and then we start augmenting things like data governance, business analysis, master data management. All those things get incorporated into this discipline, but this discipline becomes the core of it.
So Blair, we've got about 10 minutes, and I'm sure.
Yeah, this is my last slide.
Yep. There's a whole bunch of people who I think are about to start waving their hands, but.
Okay. So basically, I'll do this really quick. So, our methodologies for creating systems is dated. It hasn't changed since the beginning of time. We have an integration last approach. And as long as we continue to do that, we are always going to struggle with integration. We can't put icing on top of, the silo systems that we create. And I think that this 3D approach will let us break barriers to take on challenges with conglomerates that we could never deal with our current approach. And these principles are all developed, from the bottom up for integration. And I feel like if we were, as an industry, able to do this, it would be like the difference between, GPS, compared to maps and compasses, and what a paradigm shift that was. So as an industry, if we were able to get on this and start creating it and building on this, it would be that kind of a difference. So anyhow, that's
Michael's got his hand up.
Yeah, okay.
You're muted, Michael.
Okay. First of all, we're totally on the same page. So much of what you said is exactly how we think about things and how we do things. So that's just the first point. And others will probably second that. But a more specific question, what you're calling an application framework, I'm wondering what that is exactly. And my first thought that comes to mind is it's like a system architecture or it's a platform. How do you see this application framework?
the application framework is, like if we go in and we look at like an enterprise application, it's like there's a lot of data that defines how an application works, right? There's, like there is data that defines the menu options and, what I call commands that exist. And there's a hierarchical structure for that. And that's tied into like a security structure that defines who's got access to what, commands. And then we have structures. We have data dictionary, which is, like a, metadata about the dictionary. And then we have metadata about what the forms look like, the browse forms, search forms. We have metadata to describe what workflows look like. And so in a perfect world, we would look at that in the same way that we look at core data. We'd say, okay, what is the core features that need to be in a application framework? Is things like, well, we need people to authenticate. We need to have a menu system that only shows them the menus that they have access to. We need to be able to let them browse data, search data, edit data. We need to allow them to be able to drill down. We need to be able to have, so it's like that, right? And so once this application framework is created, we would substantially improve the efficiency with which we could create systems. And in fact, our historical experiences, you don't need the same level of expertise to create the systems now. We can take developers right out of school and, and make them productive, very quickly. So does that answer your question, Michael?
Yes, thank you.
Do you have one, Dave, or there's a couple in the chat?
I've got a bunch, but yeah, go ahead and take the ones in the chat.
So the one in the chat went back to sort of that core data you were talking about, asking if you had any sort of modeling patterns that you use, that you only need to add new requirements. I think there was another one similar to that. Yeah, that's essentially it, sort of core modeling patterns.
Yeah, there are some patterns, and there's some patterns that are different than what we have now. One of the key patterns I think that is different is we have this ability to, or we require this ability in this system to have not just a record be owned by a single parent, but by any parent in the system. And so a good example of that is when we've got activities, we're performing activities. Somebody does an activity, they do something for somebody, right? But lots of times when you start to look at the activity data, they're not just doing it for somebody. They could be doing it for something. They could be doing it for an asset, in terms of it's not done for Bill, it's done for this truck, or it's done for this land parcel. And we need this ability to be able to take data and to connect it to any object in the database. A good example of that is in the financial system too. We might have journal entries, and often with journal entries, we will connect them to, well, lots of them they're connected to nothing, but they could be connected to, if it's a receivable, it's connected to a receivable account. If it's a payable, it's a payable account. But they could be connected to a project. They could be connected to an asset. They could be connected to almost anything, and that's the goal, or that's the architecture, is that you can take that and connect it to anything. So it's really critical if you're going to reuse that functionality.
Yep. I guess I'm going to get the last word then. So yeah, I like your decomposition of the problem. I like your principles. It fits right in with what we're doing. But we, not just Semantic Arts, most of the people on this call, and actually thousands of other people in general, have chosen to do this with the W3C's open standards.
Okay.
So, and those include the URI as the way of defining identity. Secondly, a graph as the major structure, not tables. And once you go to the graph structure, you'll find that pattern you said is just automatic. Things can be attached to anything. So that becomes much easier. We're at Semantic Arts and this community have decided to go with GIST, which is our core model. It's freely available on our website. You can download it if that works for you. Knock yourself out. Your other 2 points, which I think are great, governance. There's almost always a governance component here. There's some things in the W3C standards that help with governance. So actually, the graph structure itself can help you a lot, but also there's a provenance ontology. There's a lot you can do with governance. And I think what you're describing as an app framework is what we've come together in the data center architecture to say, these almost exactly what you've got there. Here's the main components, and there won't be one architecture to win them all. It's almost like a reference architecture. These are the pieces, and they're almost exactly what you say. Authentication, authorization, constraint management, validate, right up and down the list. And various vendors are coming and supplying some of that, but we want it to be interoperable, not a monolith, I think.
Yeah. Well, I think, it really comes down to the goal, right? In terms of how big are we thinking in terms of, and if we're thinking that, I just think as an industry, we can't continue to create silo systems, right?
Absolutely.
It's like, and so that's a big rethink in terms of how systems get created. And so, but yeah.
Absolutely.
Anyhow, I really appreciate you guys' time. I mean, you guys are all busy people, and for me to get like an hour to talk about this stuff, with you, I really appreciate it. And if you've got feedback, if you want to go check out the website, got feedback for me, you can reach me at Kjenner at there it is. Kjenner at Method One Software, or you could, if you're, so there's some of the other things that, you could do to contact me. So
would you be able to share a version of this deck I can email out with the recording for folks?
Oh, I could, absolutely. You want to, yeah, sure.
Yeah,
if you just might email it to me, I'll be emailing out a recording, and I'll include it with that and include you in the email as well.
Yeah. Okay. Well, that sounds good. I just lost where you guys are here now. That would be great. And, like I said, if I'm very interested in your comments and direction and anything that you've got. And if there's something that you want to work on together, you can let me know.
You bet.
Very good.
It was great. Thanks.
Well, thank you.
Blair.
Thanks for your time.
Thank you very much.